Sorry I'm late. I was reading a book on chemistry jokes. Here's one that's apropos for today. If H2O is the formula for water, what is the formula for ice? H2O cubed. H2O cubed ice. Well, welcome to Chemistry with Mr. B. I'm Victor Brandalise, aka Mr. B. And today, I want to investigate about ice. Do an investigation. I mean, ice. It's water, but it's frozen. It's in a solid form. Yet the ice cubes, they float on the water. And I ask my students, well, why are they floating? And they'll say, well, because it's lighter. And I think about it, lighter. Well, do they mean it weighs less? Or do they mean it's less dense? I'm not ever sure about what they mean. But if it's lighter, that must mean the mass is different. Because when you talk about lighter, you're talking about the weight. And heavy or light. And typically, though, when we weigh things, we're really getting an indication about the amount of matter that's in that object. Weight depends on gravity. So you would weigh less if you weighed yourself on the moon. But if you take your mass and determine your mass, which is what we do with a lab balance, your mass would be the same, because mass is the amount of stuff in matter or in the material. So today I want to do an investigation about ice. What happens to the mass of the ice when it melts and becomes water in a liquid form? And so, what is your hypothesis? What do you think happens? Do you think the mass of the ice would decrease as it melts? Do you think the mass of the ice would increase? Or does the mass of the ice stay the same? All right, well, to test our hypothesis, I'm going to set up an experiment where I take an empty, dry beaker, get an ice cube, place the ice cube in the beaker, make sure I dry off my hands. Now, I'm going to place some saran wrap over the top of the beaker because I want to close it off so that nothing can get inside the beaker from the outside, and nothing from the inside, which would be the ice or the water, can get out. Because I want to see what happens to the ice's mass when it melts and becomes a liquid. So I've got what I call a closed system. My system is investigating what happens inside the beaker. So, got my beaker. I'm going to go get the mass of the beaker on a lab balance. Now, a lot of times when I say mass, you may say, well, you're weighing it. Okay, yes, but I'm getting the mass of it in grams. And then I'm going to let the ice melt. And then after the ice melts, I'm going to get the mass of the ice cube with the beaker and compare them before and after to see what happened to the mass. Now, when you do an experiment, typically you like to do it more than once. So I'm going to be doing 3 trials, which is pretty typical. And I want to see if my results are reproducible and consistent. All right, so let's go to the lab balance. Come on. Okay, so here we are at the lab balance. Let me turn it on. And there's the reading. Let's see. Okay, so it's reading 0.01 grams. That's going to the 1/100th of a gram. So here's beaker number 1. Let's place it on the lab balance. 73.12 grams. All right, 73.12 grams. Let's check that again, just to double check. 73.12 grams. All right, that last digit there, the 2, very often could be a 1 or it could be a 3. That number can vary because the balance is only accurate or has precision up to 1/100th of a gram. So it's always plus or minus 0.01 grams. So let's just see again. 73.12 grams. Oh, now it says 73.11 grams. So that last digit always is the questionable one. It fluctuates, and so it's okay if it reads 73.11. All right. I had 73.12 grams. Now here we go with beaker number 2. 64 0.11 grams. Let's double check that. Make sure we've zeroed it. 64.09 grams. All right. And now let's go to beaker number 3. Make sure it's zeroed. 68.36 grams. 68.36 grams. Let's just make sure I want to show you again. Oh, 68.36 grams. So the level of precision is always that last digit, which could be a 5 sometimes, could be a 6, could be a 7. It always varies. But 68.3 is known for certain, with certainty. All right. Now, let me show you our results. Or not results, our data so far. In our beaker number 1, the mass is 73.12 grams. Beaker number 2 at 64.09 grams, and beaker number 3 at 68.36 grams. All right, let's go to take the beakers over to the hot plate, and we'll put them on the hot plate. Okay, here we are at the hot plate. Now I'm going to place beaker number 1 on the hot plate, beaker number 2, and beaker number 3. The reason I'm using a hot plate is because, well, if I was just to allow the ice cubes to melt on their own, it would take about an hour and a half for it to melt, which, an hour and a half was not very practical for a video. So I'm using a hot plate. I've got the hot plate on a very low setting, just warm, and it's going to melt it in about 15 minutes, which is going to allow us to be able to do it in the video. And actually, I'll be using time-lapse photography. So if it takes about 15 minutes, it'll probably take about 10 seconds in this video. Well, anyway, so that's what we're going to be doing. We've got it at a low setting, very low. I can just touch that. And just, by the way, if you're looking to have some fun sometime on a Saturday night, one of the things you can do with your friends is get together and put some ice in a glass and watch it melt. That's a lot of fun and can be very exciting for an hour, hour and a half. All right, so that's something for you to do. All right, here we go. We're gonna let this melt. So. Wow, that was fast. Looks like it's all melted. I mean, that took about 15 minutes. I mean, that was fun watching it melt. But oh, look at that. Oh, number 3's all gone. Number 2, the ice is all gone. And number 1, boy, that took 15 minutes, but seemed like 9 seconds. Chemistry really flies. I mean, time really flies when you're having fun in chemistry. Oh, wow. All right, now. What we're going to do is we're going to go get the mass of these beakers, and see how they compare with our initial masses. Let's go to the lab balance. Okay, here we are at the lab balance. Let's turn it on. All right. Make sure it reads 0.00 grams. Let's get beaker number 1. Put beaker number 1 on there. The mass is 73.11 grams. Let's just double check that again. Let's just see. 73.11 grams. All right, now beaker number 2. We're going to go with beaker number 2. 64.10 grams. 64.10 grams. And finally, beaker number 3. Beaker number 3. 68.38 grams. 68.38 grams. Okay, now, well, let's just look at that again. Seemed like the number was different there. 68.38 grams. Yes, all right. So now, let's see what our results look like here as we go to our data table. In our first one, in the beaker, it looks like it lost mass. The difference here is a negative 0.01 grams. So it's off by 0.01 grams. But again, that's within the range of this balance, which is plus or minus 0.01 grams. Number 2, it's difference of, it looks like the mass is a plus. The mass went up 0.01 grams. again, within the range of the balance. And thirdly, let's see, this difference is, it looks like it went up 0.02 grams. Well, that's a little higher than I expect, but what we want to do is go back to our seats and let's take a look at the results so that we can maybe make some conclusions. All right, here we go. Okay, here we go, back to our seats. All right, well, now, our results show that in 2 of the beakers, there was a change of 0.01 grams, an increase of 0.01 and then a decrease of negative of 0.01. And in one, an increase by 0.02 grams. Now, that seems like we didn't get exactly maybe 0.00 grams, but I've done this 15 trials here. And what I want to show you is on these previous trials, this is the kind of results that I got. In 9 trials, I got a difference in mass of 0.00 grams. All right. 3 of the trials, I got a difference in mass of plus 0.01 grams. 2 of the trials, I got plus 0.02 grams. And then 1 of the trials, I got plus 0.03 grams. So, in the majority of the cases, it seems that the mass is falling, the change is within the range of the balance. And so having 9 examples of a change in mass of 0.00 grams, I think we can make a conclusion here. All right. Now, it's important to keep in mind that, as you can see with this beaker, there's condensation, moisture up there. And the purpose of the saran wrap was to make sure that none of the water vapor got out. And that was important because in beaker number 2, our change in mass was, well, it showed a plus 0.01 grams, which again is, for all intents and purposes, a change of mass of 0. All right, because this balance can be plus 0.01 grams off or minus 0.01 grams off. So, I think we can say for our conclusion that the mass does not change when ice melts and goes from a solid state to a liquid state. So our investigation has shown that mass stays constant during the melting process of ice. So it's interesting. If the mass of ice is the same, it's not heavier, but it's not lighter, then why does ice float on water? Well, that's an investigation for another time. You know, I think this lab, or this investigation with ice, was a pretty cool thing. Pretty cool lab. Oh, there's the bell. Well, it's been another great day in the lab. Thank you for watching this video, and please tell a friend about Chemistry with Mr. B. I would tell my friends, if I had any friends, but I don't have any, so would you please tell your friends? All right, well, you have a great day, and remember, old chemistry teachers never die. They just fail to change states. What? You're still here. Oh, you want another chemistry joke? Okay. All right. Here it goes. H2O is water. H2O2 is hydrogen peroxide. What is H2O4? Drinking. What is H2O4? It's for drinking. All right. Well, have a nice day and break a beaker.